Hello there. Today we'll be doing ancient astronaut theory. You are given a string dictionary representing a partial lexiconic graphical ordering of ancient astronaut dictionary. Given a string S, return whether it's a lexiconographically sorted string according to this ancient astronaut dictionary. So an example is dictionary is equal to ACB, and the string is A, four A's, H, C, I, B. That is, output is true. The constraint is that A comes before C, which comes before B. Let's check out example 2. In example 2, we see that dictionary ACB, and we have A, C, B, and then the C. So it is false because we found the last character is C, which comes after B. A method that I think would work best here for this type of problem is to see whether or not we have pushed past that particular character in the dictionary. So or if we have, or whether we not have seen the item in the dictionary. So what that means is that we will map each item to a sort of like index in the dictionary and map all those items in the string to that particular map. We should see in this particular map that all the items is going to be greater than the previous item, greater than or equal to. And if it's less than, that means it's an item that is out of order, that's not sorted. So we'll do this in 3 different ways. Well, 2 different ways, and we'll get to another method afterwards. Okay, here we go. So first thing we do is that join the room. First thing we have to do is set look at every item in the dictionary and get an index for it, for each item in the string. So let's say our x is equal to for char in S. If char is in the dictionary, then we will give it an index of the char in the dictionary. So now all the items should be sorted. So I is equal to 0. So while I is less than the length of x minus 1, we will do an if any item, it must be in order, so plus 1, is less than x of I, then we'll return false. And if I plus equals 1, then we'll go through the entire t of x and return true if it all passes. So let's see. Let's run this. And looks like we have passed. It's quite slow. So let's try another method. So this time we will do a another sort of array of seen items, and it should be seen in the correct order. If it's the items have been seen in the wrong order, then well, will be false. So here we go. Index map equals for I and C in enumerated dictionary. So that looks for each particular index and character in the dictionary. And what we're going to do is we're going to create an index map where C of I, so each character is going to index the index of that character in the dictionary. We're going to create scene equals an array for C in S. If C in index map, scene.append index map of C. So for every character that is that has a character in the dictionary, we're going to append that particular index of that character into this particular array, similar to the previous one. And we'll return scene is equal to sorted of scene, because, well, if it's sorted, then everything is in the correct order, and if it's not, then it is not. So let's run it again. Oh, it looks like there's an error. Let's see what happened for C. Enumerated spelled wrong. Enumerate. Run. So we submit, and it's a little faster. So both of these methods require us to use O of n space to do the problem. Suppose an O of n time. Suppose I wanted to use O of 1 space. How would I do that? I think I would have to reuse the information that I have in the dictionary, which is not a dictionary, it's a string. So we're going to instead going to count when it is not equal to the item in the dictionary. So what that means is that if it's not equal to, we'll keep on moving. If it's in the dictionary and it's not equal to any of these items, and if n is ever greater than the length of the dictionary, that means we have multiple items that is out of order that in our dictionary string, and we'll return false. So let's try this one. So n is equal to 0. So for I in range length of S. So for every item in the string, and if S of I is in the dictionary, then we will make sure that we'll get to that point in our dictionary. So if this is n is ever going to be greater than or equal to the length of the dictionary, that means we have gone out of bounds, and we have you know, either an item that comes after a dictionary that's not found. I mean, that's in the previous part of the dictionary that that's not out in order, and also if we have an alternating order and we just can't do it. We just can't find it. So run. None. Oh, right. Return true at the end. Run. Submit. And here we go. That is another answer to the ancient astronaut theory problem. I like this one because we're using the both strings to match to work on each other, and we're using O of 1 space in a O of n time. We also can detect any errors much earlier by moving through the dictionary instead of building up a list. Well, if you like this video, please hit like. If you have any comments or questions, please list them below in the comment section. And if you want more of these videos, please subscribe. And that's all. Thank you very much. See you in the next one.